Welcome back to my definitive laser series. This is going to be part 4. In this part, we're going to be covering colors. And more specifically, we're going to be expanding the system that currently works with the colors. Because right now, each color is kind of specific and we can't do much in the way of changing that. So today, we're going to go over setting up the system so that we can change the colors based on a decision we make on the handler. So for instance, we're going to be able to determine whether we use a merge of all the colors that are hitting, the first color that hit, or the last color that hit. And when I'm saying color, I'm talking about the color of the laser that hits the object. So let's get into it. The first thing we want to do is actually a change to our emitter. So in the emitter, previously we had our current color. Now we're going to change that. We're going to keep our current color, but we're going to make two new variables. The first one, so we'll duplicate the color, is called override color. And what this one is very simply, we're going to add a boolean as well to say, hey, do we want to override the color of the laser so that no matter what happens, it will always be that color, no matter what hit it, no matter what other conditions we've set, it will choose this color. To get that to work, we also need a boolean to check. So we are going to get that right here by duplicating again, and we will look for use override. That's what we'll call it. And this is going to be a boolean. So click, select boolean. And for these two, it's important that we make sure these are instance editable, because otherwise we can't actually change them on each cube. So now if we, for instance, compile and save, we can actually tell this specific cube here, for instance, if we go down to its emitter, to use a different color. If we tell it to override, it will do that. Now, that's what we're going to set up in a second. So before getting into making this actually work, because right now we can override it, we can change its color, but it won't do anything. But before we actually do all that, we're going to add the last thing we need as far as building blocks, and that is an enumerator. So in our building blocks, we want to right click, we want to go to blueprints and enumeration here, and we'll call this color selection and open it up. And we have 3 enumerators we want, so add 3 times here. First one is going to be first laser hit. Second one is going to be last laser hit. And the final one will be merged lasers. And so this way we can actually determine which type of color we want to use based on these conditions, because there aren't any others. So we can close it, we don't need it anymore. In our AC handler, where we do most of our controls, we're going to make a variable that will handle that. So we're going to create a new variable, and we will call this, use color. Or maybe used color is probably better. And so this is going to be the enumerator we just made. So select the boolean, change it to e_color. And we want to look for color selection. Now that we have this, just like our conditions, we want to make sure that it is visible, because if it's not visible, we can't actually change it based on each actor. So now if we compile, we can tell this, if we just select our handler here, we can tell it to use the first hit laser, the last hit, or the merged laser itself. So for now, we'll leave it by default there. Still doesn't do anything yet. So let's get into setting this whole system up. So we can actually close our A laser, we close our A cube, our A spawn, our bounce, and our reflect, because most of this is going to be between the SC emitter and the AC handler. So first we're going to start in the AC handler. To get this to work, we're going to need 2 linear colors. One is going to be an automatic calculation of the merged color, and the other one will keep track of which value we actually want to pass by, because we're also going to use the merged color as a condition to whether a system can be activated. So we need 2 different variables just to make sure we keep the visible color different from the conditional color. So we'll create a new variable. This variable we called merged color, and it will be a linear color for the type. So search for that, and we can duplicate this, and this one will be called pass by color, and just remove the space there. So once again, just to make this clear, merge color is used just to get all the colors added up together, and pass by color is the color that we will be sending to our emitter if it is needed. So compile, and let's get into it. To get this to work, most of it isn't actually going to happen within here, because what we want to do is based on our override here, we want to choose between our override color and this color right here. So that will be done in the emitter. So we're just going to start by simply making a get function for this pass by color. So we'll say get visible color is what we'll call this. And what we're going to do is we're going to put a sequence here. And on the return of the sequence, we're going to return color. So we're going to get our pass by color, plug it in here, and this will be the return value. Now we want to make sure this is pure, that way it's easier to handle. And next what we're going to do is we're going to set our pass by color. So the pass by color, to set it, we're going to use our enumerator here. So drag it in, hold control, and let it go. And we want to use a switch for the color selection here. Now, so what we're going to do here is we are going to get our lasers in queue for now, although this will change in the next part. This for now will do just fine. And because we're talking about our first laser, we are going to say get a copy, and we're going to use 0. And from it, we will get override color. And so this will be the color of our pass by, because we are simply using this, because by default we will use first laser. So we'll say set pass by color to our override right here. Now here we're going to do a copy of this, because if we're talking about the last, it's the same thing. The only difference being instead of 0, we will say last index, and last index will go in right here. So now we have our last index, and we will just line this all up right here. And we will just say set pass by color. Plug this into the last hits, and now we have our two basic ones. And the only one we have left to do now is the merged. Now, for the merged, we need to get our merged. So pretty simply, we're just going to say set pass by to merged. But one thing we do want to do later on is we're probably going to make a macro out of this as well, because we want to make sure that this is always set to or clamped to the value of 1. And the main reason for that is because what we'll do when setting it up is we're going to say if a laser hits the cube, for instance, then the laser color will be added to the current laser color that is merged. So this can sometimes result in having like 5, 5, 5 if 5 lasers have hit, for instance. And that can cause an issue later down the line, especially with the conditional system we're going to set up later. So we're going to make a quick function here to handle that. So we'll just make it now while we're at it. And very simply what this function is going to do, because we'll use it elsewhere as well, is we're going to break our color. And we're going to make color here. And we're just going to make sure that we clamp these 3 values here with clamp float between 0 and 1. So we'll just copy this 3 times, plug the values in for each of them. And for alpha, we'll leave it at 1 all the time because it doesn't really impact much, but that way we don't have to worry about it later. So I'll just line these up a bit, plug this in here. And here we can collapse the whole thing, so even merged color, and we will right click and say collapse the function, call it get merged color. And so we will turn this into a pure, and we will connect this up right here. So now, if we call get visible color, we know which color we're talking about without having to do a for each loop or anything through all of these, because we'll be doing it as we go. So to set it up as we go, we're going to need to interact with these two right here. These two right here. So we have our laser added. Now, we know the laser has been added, so we're going to add it to our merged color. But we're not going to do that all the time, because if this, for instance, doesn't need to merge, then we don't need to actually check the merged color. And later on, we will do an AND to check if we are using the conditional merging system as well. So here, we're just going to say, is it double equal? And make sure you choose the top one here. To merge, and if that is true, so on the branch right here, if it's true, then what we'll do is we will simply get our merged color, we will say plus, and we will set the merged color back to this. So just like this, there we go. And for the input, or the second B here, we want to get our new item, and from it we will get our override color, which we just used before. And there we go. And so now we have something that adds the laser. Now we're going to copy this and we're going to remove that value if the laser gets removed. So same thing here, plug it in, and new item is the same here, same name. And instead of plus, we will say minus, plug it in, and now we do have our merged color. So let's test if this is working by going into here and let's see. Well, actually, no, we'll just set it up entirely because it's probably easier to see if it's visual. So now, instead of this whole thing where we activate the laser this way, we're going to make another function to handle it a bit better. So here, we're going to remove this for now. It's not necessary, and we'll make some changes, or we'll make a function for this to work a bit better. So in compile, we'll compile that, and we will close both of these for now, and we're going to make a new function called set laser color. And so we're going to start this off with a sequence. And from the sequence, the first thing we're going to check is, are we using our override? Because if we are, we want to make sure we use our override color and not our actual pass by color. So if override is true, we want to get this. We're going to promote it to a local variable here, which we'll call L temp color, we'll call it. So plug this into true. And on false, our temporary color here will be set to the color we just created, so or the function that we just created. So from our components, get our owning, and we will say get color or get visible color, because we don't need the merged here. We just want to see if it is visible. So like this, and then what we need to do here, and the reason we have a sequence here is because normally this would be enough, right? We could just, instead of our temp, we could just replace it with our current color, which is the one that gets set in our activate right here. But the reason we don't do this is because this happens on spawn. This happens when the laser comes in and gets hit, and it will create a new laser. Now, the problem with that is, well, we only call that on spawn. So what happens if a second laser hits the cube, but it doesn't need to spawn a second laser? It already knows that. So we need to have another system for that. So we're going to check if this actually makes a change to our actual system. So for that check, we're simply going to look if our current color, so this one right here, is different from our new local variable here, which is temp color. And if it is different, that means that we need to make a change. That first change being we're going to set our current color to our temporary color right here. Now this is mainly useful for the conditions, but it also won't change the color if we don't set it up like this. So what we're going to do here now is we're going to say get attached laser that we created and make sure that it changes color as well. So right here, we'll get this and we will say change laser color, which we set up earlier for this exact purpose. And so we'll get our current color and we will update it. Now this is mainly in the case of having a merge laser or the last laser, because in those conditions, the next laser that hits actually makes a difference. So, or in most cases it does. So if we compile this, we're going to want to place this function right before we call our activate laser. So we'll call set laser color right in front of our activate laser. That way we know the color that we're talking about. Want to make sure we only do this here. And the reason we only do this here is because here, it can't possibly know that because the system is inverted, meaning it's when it doesn't get hit that it activates. So we leave it like this. Now we can compile and save, and if we play here, normally everything should still work the same. There should be no difference, or apparently there is. So the laser here is purple for some reason. If we push this as well. Okay, so that is correct. But if we make it hit a blue one here, okay, so it is working. I think that there is an issue with the actual bounce. So that's on me because I thought we didn't have to do anything there. We actually do. So AC bounce does need to have some logic here. So in the spawn laser here, we have to do a little change. And this will be here. We're going to say set color. Set laser color here, and that should function if I'm not incorrect. It might have an issue due to the fact that we haven't told it any information about the handler though, so I need to double check. No, this should be fine. This should work. So if we play now, there we go. So now it's blue. So it was an issue of the fact that I just didn't set something up in the handler, in the bounce. So just to confirm, to get that error to be fixed, we just want to make sure we add a set laser color before we activate the laser inside of the spawn laser of AC bounce. Because by default, it will just activate laser. We never told it to adapt the color. So now it does that as well. So that will solve that issue. Now, the next thing we need to do, because this is almost complete right here, is we want to check whether it works with multiple lasers. And it most likely will not, because we still have one extra thing to add. So let's just see if I'm right and if something is going to go wrong here. So I'm just going to get rid of all these for now. I'm going to move our cube a bit forwards, and that should make it hit here. And we're going to add another laser here that will hit it, but we're going to change the color so that it hits with something that is blue. Now, I'm not sure why this one is blue, unless it is. Okay, so that's a bit odd, because it's spawning blue, even though this should be purple. Sorry, that's my bad. The reason for that is because by default in our our actor, we want to make sure that we override here, because it should always be using the override color. And we need to actually make the current color invisible. So in our SC emitter, we're going to make sure that our current color is private, because we don't want to actually see that. We only want to see the actual override color here. So now it should be purple. Or not. Apparently not. Sorry. I know why. And the reason why is, once again, in our event graph, I forgot something. Right here in our event begin play. So this is an AC handler. The problem is we are telling it to stop hitting here, which is inverted, which means it doesn't change the color for our SC emitter. So what we want to do is make sure we do here as well, set laser color. So we'll use the actual override. So just like this, we'll add a few reroutes just so it's a bit more readable. There we go. Detach that one with alt click. And so now, there we go. We have red and we have purple. So to check if this is working, we're going to move this back to where it was, which should be about right there. And okay, so this needs to come a bit further back and a bit more to the left. So here, two lasers are hitting it, and one of them is passing through for some reason. Oh no, sorry, it's not passing through, it's that it's spawning the purple one. And so here, this is correct, because it's taking the first one that hit it and letting it know that that is the laser it needs to appear, but there's an issue. So I don't know if it may not be obvious here, but if we block it, purple isn't hidden anymore, so it should have become red here, but it's not. It's staying purple because we haven't set up a system to update the laser color, so to speak. And so that's what we're going to be doing now, and right now the same thing is if we would tell it to merge, it wouldn't understand, it wouldn't be able to do that either. So to do that, we need to make a new function inside of our building blocks and our BPI, our blueprint interface. What we'll call this is we're going to call it I call it an intermediate change. And so what this is for is it's mainly if a change occurs with either a new laser hitting, a new laser deactivating and not hitting it anymore, but it doesn't modify the actual conditions to activate or deactivate. So this includes colors. So that's what we're going to be doing. So the input is a laser. So we're going to say a laser. And this is just going to be the laser that has changed the system. So this will be called modified. And this can also include if laser A that is hitting object B changes color. It will also call right here. So compile and close this now. To handle that, we're going to go into our handler where we already are now. And we're going to call that new function. So in our interfaces, we want to look for intermediate change. And so here, all we want to make a specific function, a new function for this, just to keep things a bit tidy, because this can get a bit messy here. So it's a bit easier if it's actually a specific color. Drag the modified out, select it, right click, and call collapse the function. This function will be called Recalculate Colors, and we'll be using this in another few spots as well. So in Recalculate Color, I'm going to start by just moving this to the top right here, and we will start off by doing a branch later. For now, we won't be doing this, but we're going to put a sequence here, and later we'll be adding a little function here with some conditions. So what we want to do is if our used color is using our merged colors, we want to recalculate the merged colors because they're different now. And we can't actually take into account unless we make an entire new map for all the colors, but we prefer to avoid that. This is, I think, less heavy as far as that goes. So branch. And so if we're using the merged colors, we want to recalculate them. And so the way we do that this time is we're going to first set merged colors back to black because we do this by a sum. And what we'll do here is we'll use a for each loop through the lasers in queue. And with the lasers in, with these, we will say get override color. We will say add, and we will be adding our merged color back into it, which we will then be storing in itself. So the merged color will go right here as a set and plug it all in. And so after this, on our second part of our sequence here, we're going to start off by doing a for each loop through our components and letting these components know that we also want to call the same function here, which is intermediate change. And the modified value is, once again, this laser, which we just called here, modified, sorry, which is our input. So call input pin right here. And if this causes a change, we want to make sure we call laser stop. Actually, no. So we're not going to do anything here. This is going to be a part of the conditions, which we'll add later. So for now, this is okay. And so now with this, we're going to let all the other objects know that they need to handle or change their color. To do that, we'll go into our SC emitter first. And in our SC emitter, we will call that new function. So right here, intermediate. And the first thing we want to check is, are we inverting the system? So right here, copy this branch. Is system inverted? If it's true, we don't want to do anything. That means it shouldn't be handled because it's inverted. But if it isn't, we want to say set laser color again so that it recalculates the color of the laser. And because in here we told it to update the laser, it will do the same for all the following ones. So right here, we won't do anything else. Later, we'll be checking conditions as well, whether we keep the laser activated or deactivate it. And that will be all here. Now, inside of the laser itself, we actually do need to do something as well, because each laser hitting needs to also inform its targets that it also needs to call the same function. So from here, this is good. We don't want to change this. We're going to get our previously hit lasers. We are going to turn them to an array. And with this array now, we can let it know that it needs to tell them that the intermediate laser has changed. So we're going to call here intermediate change and make sure you use the top one, not the BPI lasers. And with this, we'll plug in our self here because the laser itself has changed. And so we'll just need one last thing, and that is in our bounce here, because we need to do the same thing here as well. In our event graph, so close these two, we're going to use our intermediate change again. So what we'll do here is we're going to do a for each loop through our map here, and we're going to say get the keys, and I believe it's the keys or it's the values. I think it's, yeah, so we'll go through the values, and for each of the values, we'll tell it to recalculate the laser color, just to make sure. Or not to make sure because it's necessary. So we will say set laser color. And in doing this, it will change the color of the laser attached. So this should do it. We should have everything now set up. So if we play, so now we have purple. But if we block purple, it should have become red there. It doesn't seem to have done that. So why not? Sorry. So I made a little mistake here. So this is good. We want to actually turn this into a function as well. So we're going to get our input pin here because we need that to be separate. Select this, right click, collapse it to a function. And this will be called component color change. And so we'll just leave it like this. And the reason we need this is because right now, at least in our current situation, if a laser stops hitting, we also want to call this here and say that that laser is no longer connected. And so we don't need to do this on the start. Oh, okay, I see the reason. So the reason is because right now, this should be also setting color override to value as well. not just the actual vector itself. So let's see if that fixes the issue. Don't think it will, but it should have been done, yes. So that doesn't fix the issue, but that should be set up like this. That's my bad. Okay, so I know what the issue is, and I think it's because I'm a bit stupid. I made a very, very big oversight, which I shouldn't have done. And that is right here inside of our SC emitter. So I made a big mistake here, where here when we say start hitting, I never told it to not do this if we already have a spawned actor or a spawned laser. So we want to get our attached laser here, drag it in, right click it, and make sure that this only gets called if it's not valid. Because here, we do want to change the color, and the color will change the currently attached laser, but we don't want to activate a brand new laser if there already is one. There's no point, it already exists. So right here, we want to compile and save, and this should fix the issue. So delete it, that's already better. And so we don't want it to do that. So we want it to change the color. So let's see that. Okay, so the reason that is happening, and so that's very much linked to our conditional system we're going to set up in the next part, is right here. It's saying we're not hitting anymore. So it's going here and saying, well, we're not hitting the laser, so we should get rid of it. It should be removed right here. But the thing is, we can still technically spawn our laser. So we're going to add a condition here for now, and we will have a condition here later, but this condition is going to change as we go. So right here, it's going to be right click or R to add a reroute, select it, collapse the function, and this will be called can spawn laser. And this is going to be pure. And all this is for is just so that we can check whether a laser can still be spawned here from the emitter. Now, most of this will be done in the handler, but some parts will be here. And we're going to open this. And all we're going to do for now is we're going to get our owning handler, and we're going to say get in queue lasers. And if this is not empty, then we can spawn our laser. And if we can spawn our laser, then we don't want to deactivate it because that means it can still exist. So we will call here, and this should now, if we block this, become blue. Because now it knows that there is still a blue laser hitting, and it will adapt it. Now, if we let this go through again, it becomes magenta again. We still have just one laser attached here. So now it is working correctly. And if we can double check this by blocking this one now, it just becomes red because it's only being hit by the red laser. Same thing, obviously, if we re-put the bluing, it becomes purple or magenta. So let's just do the last tests with our different modes here. So that just worked for our merging. Let's check if it works with our first hit. Now our first hit should be blue because it's the shortest one to get there. Now if we block our blue though, it should become red because red is still the first one hitting. But if we let blue hit it again, it should stay red because red in the array is still technically the first value. So if we block this one again, it'll go back to blue because blue is now the first element in the array. Now let's do one last test for the last one. So check if the last laser hit works. Compile, let's play. And so now it is red because the red one takes the longest path to reach it. If we block the red, it becomes blue. But this time, if we let the red one hit it again, it will restart to be red because it's the last one that hit it. So right here, it re-becomes red just like intended. So thank you for watching this part. It was a bit of a mess because a lot of this is very much linked to the conditional system we'll set up in the next part. So that's why it's a bit of a mess. I hope you still managed to follow. Thank you for watching. Thank you for everybody who's supported me on Patreon. I'll say this again, but if you want the project files for any of the videos on the channel, except this one, which will be out in a few weeks, you can find them commented on the Patreon if that's something that you would like. Thank you for watching, and I will see you in the next part. Goodbye.